Welcome back. My name is Melissa with the Abbey Community School Society, and we are here for our next science experiment. This week we are going to be making an electric circuit and conducting electricity and learning which materials conduct electricity and which materials don't. Okay, so before we get started, do you remember our three very important science rules? Make sure you don't eat or drink anything during a lab today. Make sure that if you are smelling, you are wafting. And last but not least, don't have your head all the way over your science experiment in case something were to splash up and hit you in the face. This experiment, we are using electricity. So this one requires adult supervision. Okay, so our lab today is conducting electricity, and we will need these items that are on the table. So you may as well get all of your items out as well. We will need some tin foil, a battery, a light bulb, some masking tape, some scissors, and a few different objects that we'll use to see if they conduct electricity. So I have a nickel or a coin. Any coin will do. I have some plastic toys, some paper clips, a little piece of cork, some rubber bands, a clothespin or something made out of wood, and a leaf. Okay, so we're going to try out all these things to see if they conduct electricity or not. So we want to first build our circuit to know if we can light up our light bulb just with using a few simple materials. So first things first, we want to take our aluminum foil, so you might have it in a roll, and we want to cut out a square of tin foil. But this is too big. We want to make 2 strips. So we're going to cut this page in half. All right, so they don't have to be perfect. Now we have 2 pieces of tin foil. We want to fold these into thin strips. Okay, so you can watch me first and then try it out at home. We're going to take one and kind of make it look like an accordion. Okay? So we're going to fold it into thin pieces, just like this, until the whole paper is folded. Okay, so now it's a nice thin strip of tin foil. We can even fold it one more time. All right, so go ahead now and make your tin foil into 2 thin strips. And when you're ready, you can come back to the video. All right, so now we have our 2 thin strips of tin foil. We are going to now connect these to our battery. Okay, so when we look at a battery, we have 2 ends. This end with the bump is called the positive terminal, or the positive end of the battery. We are going to take one of our tin foils and tape it on top of the knob of our positive terminal. Okay, so we want to make sure that our tin foil is touching the metal of our positive terminal. So nice and firmly secure it and push it so it molds into the battery. And then we're going to take a piece of tape and attach it. You want to make sure that the tape is pressed down firmly so that tin foil stays in good contact with the battery. Okay. Now we want to take the second end of our tin foil and we want to attach it to our light bulb. Okay. So if we look at our light bulb, there are two wires coming out from it, and each wire is a piece of copper. We want to take one of the copper ends, and these are called leads, and attach it to our tin foil. So let's do that now. Make sure that you squish the tin foil close to the light bulb lead so that it has good contact with the bulb. Okay. So now we are going to attach our second piece of tin foil to the battery. So the opposite end is the flat end, and it is called the negative terminal of the battery, or the negative end of the battery. We're going to do the same thing and attach this piece of tin foil to this side. So go ahead, you can pause the video and tape your tin foil to the battery. All right, so now you should have your battery and your two pieces of tin foil. These tin foil pieces are acting as your wires in your circuit today. Now, is this a complete circuit? No, we have to attach our our light bulb light to our second piece of tin foil. So go ahead and do that now. Did your light bulb light up? If it did, good job at connecting all your wires and your tin foil. If it didn't light up yet, that's okay. Just check your connections. So make sure that your tin foil is attached to all your wires on your light bulb and firmly attached to your battery. And that way there's a good connection and your light bulb should light up. If you can't see your light bulb, you may want to turn off the lights. Let's try it out. Can you see that a little better? It's glowing pretty good. Okay, we're going to turn on the lights again and move to the next part of our experiment. All right, so what do you think is happening right now to make this light bulb glow? The science behind it is there are charged particles moving in our battery. And our battery is made up of a very acidic solution. And these negatively charged particles are called electrons. So the electrons are moving back and forth from the positive end of the terminal to the negative end of the terminal. And they are flowing through our tin foil. And as it flows, it makes a current. So flowing electrons make a current. And as the current flows through our tin foil into our light, it makes energy, which is called electricity. And that's how we can get our light bulb to light up. Okay, so we are going to detach one of our tin foil pieces. So we're going to go back up to the battery and feel for the negative terminal. That's the flat end. We're going to go down the tin foil and take off the tin foil from the light bulb. Now, make sure you look at your light bulb. It's not on. That's because we have opened up the circuit and it's not connected to the battery. So for this next part, we are going to test different materials to see if they conduct electricity. Now, what that means is if it conducts electricity, it allows charge to flow through. So it allows current to move from the battery through the light bulb, through your object, and back to the battery. If it's a really good conductor, your light bulb will light up. But if it's something called an insulator, insulators don't let charge flow. So that means it won't let your light bulb light up. So let's try out some objects. We have our metal coin. Okay, you could use a nickel, a dime, a loonie, it doesn't matter. Anything that's made out of metal. But this one right here is 5 cents. We're going to see if this conducts electricity. So what we want to do is we want to put the nickel in between the tin foil and the light bulb lead. Okay, so that's the little copper wire that's not attached to anything. So go ahead and try it out and see if your light bulb lights up. All right, so my light bulb lit up. I have my coin in between the light bulb lead and my tin foil, and it lights up. So that would mean that this is a really good conductor. Let's try a different object. Let's try a piece of plastic. So I have a little plastic toy. We're going to put this in between our light lead and our tin foil and see if it lets charge pass through. So all you have to do is hold it in place. You don't even have to tape it. And just look at your light bulb. Mine is not glowing. So is yours glowing? If it is, then you are using a conductor. But if it's not glowing, then this toy would be an insulator. It's not letting charge flow through the circuit. All right, what to choose next? Let's try a rubber band, okay? What do you think? What is your prediction or hypothesis of what is going to happen? Do you think this rubber band will conduct electricity? Or do you think it will insulate and not let charge pass through? Let's try it out. So you can pause the video here if you like, or try it along with me and see if this rubber band conducts electricity. All right, my light bulb does not light up. So what does that tell us? That's right, it's an insulator. Let's move on to our next item, some paper clips. Okay? Let's think about it. What are these paper clips made out of? That's right, they're made out of metal. And what do you think so far? Do you think metal is a good conductor? Let's try it out. Sometimes your light bulb might fall off your circuit. Just reattach it with the tin foil. All right, so you have to secure it enough so there's a good connection. Now I've done it, and it lights up the light bulb. Did it work for you? Why don't you try more than one paper clip? What if you made a chain of paper clips so that you had 5 paper clips strung together or 4 paper clips strung together? Would it work the same? Try it out. All right, let's try our next item. I have a piece of cork. Okay, let's try this cork out. Let's sandwich it together. Do you see any light? I don't. So that means this cork is an insulator. All right, what about this wooden clothespin? Should we try this out? I don't see any light. What about if we use the little piece of metal that's in the middle of our clothespin? Let's try that out. Is that a good conductor? Ah, it is. My light bulb started glowing. Okay, so we have learned so far that lots of things made out of metal are really good conductors. I have two more things that we can try out. We're going to try out a leaf. What is a leaf made out of? Is it made out of metal? No. Is it made out of something that used to be alive? Yeah, so it's made out of organic material. Let's see if it conducts electricity. Nope, no glowing light. Okay, so good job. This leaf is an insulator. All right. Now lastly, our spoon, our metal spoon. Let's try this out. Now I think you could predict what this will do. Will it make the light bulb glow? Let's try it out. Yes, it does. Okay, good job. So if you find any other items in your house that you would like to test, you're welcome to. So I have here metal things, rubber things, plastic things. So if you can find a specific toy you like playing with, you can see if that is a good conductor or if it insulates and doesn't let charge pass through. Okay. Remember, you can always try new things in science, and if you have any other ideas of things to try in your circuit, you're welcome to do so now. Now remember, today we are using a battery with a very low voltage. Okay, so it has 1.5 volts. That means that we are allowed to touch the metal to the light bulb and touch all the connections with our fingers. But if we are using a big battery, like a car battery, we would definitely not want to use our fingers to connect the positive terminal to the negative terminal, because we could burn ourselves or get really bad shock. So just because today we are touching our circuits with our fingers, remember that if you are using other batteries and strong voltages, not to use your fingers. When we talk about electricity in your house, you might have seen cables running from your TV into the wall, or maybe from your computer into the wall. Now, on the inside of these cables, they are made out of conductors or wires that are sending information from one place to the other. But you'll notice that your wire is covered with more like a rubber cable. And that rubber, or that other material, is an insulator, so that when we touch those cables, we don't get shocked. Okay? Another example of having conductors and insulators outside is if we think about downed power lines. So if there's a windstorm and some power lines get knocked down, you're always told to stay in your car or stay in your house. So if you're driving along and there's down power lines, you want to stay in your car, and that's because your wheels are covered with tires, and those tires are made of rubber, and rubber is an insulator. So even though there is electric current running through those wires on the ground, as long as you stay inside your car, the rubber on the tires in your car will protect you from getting shocked by those wires on the ground. I hope you had lots of fun making a circuit today, and I'll see you next time.